Hello and welcome back. We're talking about section 1.1 in college algebra, and the topic now we've moved to is example 4, which is solving for a specified variable. So if you want to follow along in your book, that's where I'm at. We see the equation I equals PRT, which is a formula that we will be using in the next section. It's the simple interest formula. It's principal times rate times time. And there's too many variables in it. Unless you know some of those parts of it, you're not able to really solve it. But what we can do is rearrange the equation. And we do a lot of that in math. It's called manipulating it, moving the variables around with our rules. So we can rearrange it in terms of a different variable. Right now it's solved for I. It's in terms of I. So we want to rearrange it. In this problem it says for t. Solve it for t. So we want to get t alone. Well, this one has just got one, this is all just one term. It's all times together. So to rearrange it for t, we would divide out the p and the r from this side, and then do the same thing to this side. Divide by the p and r, and then t is now solved for, and I is p over r. And you could rearrange it and write it, flip it around, but it's equivalent, solve for t now. The next example, example B, we're solving another formula that you'll be seeing later in the semester. And we're solving this for P. Right now, it'd be easy to solve it for A. We just throw that P term across the line and it'd be solved for A, but it's not what it asks us to do. It says solve it for the P variable. So that's a little tougher because in this one, P is in two different terms. This counts as one term. Everything that's times together makes one term. This is a term, and this is a term. So there's three terms. So we need whatever variable we're solving for, P in this case, you need to get those on the same side. That's how we start it. And also if there's fractions, you always clear your fractions first. So we don't have that on this, but just keep that in mind. So I'm going to bring this minus P across the line, making it a positive P, and that's a positive PRT term. Now, unfortunately, I cannot combine those terms. They're not like terms, so that's not a route you can go. So when you can't combine terms, you factor. That's the strategy here. So you factor out, there's a common variable P. You factor that out. P times 1 makes this P, and P times 1 RT or RT makes this term. That is equivalent. In algebra, we're always making equivalent steps, so we're not changing its value. Of course, we have to follow those rules. So distributing, that is equivalent. Now P is our variable we're solving for, P times 1 plus RT. I can divide by that quantity. We call this a quantity. So exactly whatever that may be, we divide it to each side. Allowed to do that. Do the same thing on this side. That leaves P now solved for alone equals all this other. And then it's solved in terms of P, manipulated, so P is alone now. Notice when you solve for a certain variable, you can't have any stray P values over in your solution set, then it didn't go right. It has to be P equals all other variables according to our rules. All right, let's try that again. Okay, example C. Here's a bunch of variables, a bunch of terms. Solving for x. So, no fractions. Again, that's the first step. Fraction decimals, you want to clear those if possible. Second step is anything that needs distributive. So here we do have the distributive property to use. 3 times negative 5. Bringing your variables along with you. Alright, then you always simplify each side as much as possible. If anything combines on the left or combines on the right, sort of like they're two separate problems, you simplify as much as possible before you start moving things across the line. Alright, so we are not able to do that, so now we're ready to say what variable are we solving for. Notice it specifies to solve for x, so we need to get our x's to one side and everything else to the other side. So I have an x term on this side. I'm going to bring it over to be with this x. When it crosses that equal sign, it changes its sign. And everything else, throw it to the other side. So remember, when you move terms, just do the opposite. That'll be positive, and that'll change to a negative. All right, so what have we got? 6x minus 4x. This moved over, became positive 15a. That moved over, became minus 4b. And then there's this minus 2 that was already sitting there, so it doesn't change, right? It's already on the right side. Okay, we don't have to factor this time. There's only one x term, so it's consolidated. So all we need to do is divide by the 2, doing the same thing to both sides. Cancels out the 2, and then we have found x. 1x or x equals all this stuff, which is already in fine form for our solution. Now, you might ask, does that simplify anyway? This is a good way to leave it. It's fine like that. If you were to simplify it further, you could say each one of these is divided by the 2. This one would cancel and be nice for you, but you couldn't just divide this part out. It's each one of these 3 terms is divided by the 2. So if another form of the answer would be 15a over 2. 4b over 2 would be 2b, and then negative 2 over 2 would be minus 1. That would be an equivalent form. It's not that much better, so that's probably just fine like it is. All right, so let's try a couple more of those. Sometimes these are kind of tough because they're abstract. You just got so many variables in it that, you know, it's bad enough to have one variable, right? Sometimes, so bunches of variables makes it more abstract. So let's try practice that a little bit more. All right, let's see. Just looking at some problems out of your textbook. This is number 42. And just be aware, this is a good place to get practice. You have your online textbook, so you can always go to your textbook. At the end of the section, there's practice problems, and if you're doing odds, you can check your answers at the back. So it's a good place to kind of hone your skills, you know. I like the MyLabs Plus program. It's great, but sometimes it's good to get the book examples and practice on your piece of paper and just check in the back old school. So know that resource is there too. All right, so here's number 42. We're solving for W. This is a formula we use a lot in math. It's the perimeter formula for a rectangle. It's 2 lengths plus 2 widths. We're going to rearrange it. Right now it's solved for perimeter, right? So it's fine, but if we wanted to rearrange it, we could do that. And we've been asked to rearrange it for W. So just like all the others, if there's fractions, include the fractions. If there's distributing, distribute. Then simplify each side. Nothing simplifies here. Then we start moving things across the line. So it's really likewise that 3rd or 4th step before you move things across the line. And what you move across the line is the variable you're asked to solve for. Whatever variable it is, you need to move it to one side, consolidate it to one side. So W, here's the one and only W term. I want it on one side by itself. So I'm just gonna let it sit still. Then this 2L, move it across. So everything that's not a W term moves to the opposite side. And so now I've got the W terms all to one side and everything else to the other side. Divide by what's with W, and W is solved for. This is a fine way to leave the answer. Once again, there's various forms of correct answers. This is probably preferred. An equivalent form would be P over 2. And then this over 2 would reduce to just minus 1L. That is equally correct. Okay, let's try another. Let's look at number 48. This is a formula from statistics, so I don't know if you have to take statistics next, but this one you'll use all the time in statistics for finding the z-score. Right now it's solved in terms of the z-score, but if we wanted to rearrange it in terms of the x variable, we could do that. Okay, finally we have a fraction. Remember what I said, if you have a fraction, clear a fraction. So that's how we start this one. Think of this z as being over 1. So there's only really one denominator, which is the sigma symbol. So we want to times each side. That is our LCD by the sigma symbol. Do the same thing over here. On this side, it just wipes those out because they're diagonal and multiplying. Brings out the x minus the u. On this side, 1 won't cancel it out, so it's the sigma times z. So it looks like that. So now no fractions. And then no distributing needs done. And then the next step is we move things across that line. You know, if we can simplify, I guess that's next step. We can. So then start moving across the line. So we want to get the variable you're solving for all to one side. We're solving for x here. I see just one x term. I'm going to let it set still. So just need to move the minus u to the other side. And that makes it a plus u. And there's my x. So x is now alone. 1x equals the other side. If you feel better from left to right, you can always rewrite it. But it's equivalent that way. All right, let's try another. Oh, here's something we do a lot of. Let me just make this one up. We'll be doing this in chapter 2 a lot, which is rearranging a linear equation for y. If you have an x and a y variable in chapter 2, we're going to be graphing with those, and I'm sure you've peeked at that in your past where you graph linear equations. Well, it's one method for graphing is to solve in terms of y and get it in y equals mx plus b form. So that kind of goes along with what we're doing here. So looking at this equation, we want to solve in terms of y. So there's no fractions, there's no distributing, I can't simplify on the left or right, so step 4 happening here. Solving for y means get any y terms on one side, everything else to the other side. So here's my y term, 3y, take the 2x to the other side. So we've got 3y equals, this will become minus 2x, and that's a positive 7. So now we got only y terms on the left and everything else on the right. Then divide by what's on that variable to get times and divide will cancel to be 1y. Do the same thing to this side. This is a fine answer, by the way, kind of like on the last one. That's fine, but typically for the line one, we want to see it broken apart, so we would take it one step further and would say it's negative 2x over 3, or negative 2/3 x, and 7 over 3. And that's going to be helpful to us, like I said, because we do the slope-intercept method, and that'll be handy. But right now, just in theory, that's how you solve in terms of a variable. Just another example of that. Okay, let's look at another. Let's see, number 56. Okay, this example says solve for x. So, once again, no fractions. We can't distribute. Does anything simplify on the left or on the right? No like terms exist on the left or right. So step 4, moving things across that bar. So I'm solving for x. So anything that has an x in it, and we have 2 terms this time, so we're going to get those to the same side. And that's always up to you, whichever side you think looks easiest. I'm going to go to the left. So bx moves across, and ax was already there. That becomes minus bx. Everything else moves to the other side, so this b squared is moving over here and becoming minus b squared. So what have I got on the right? Negative a squared and minus b squared in either order. Okay, I cannot combine my x terms this time. That happened to us in one other earlier example, so that's factoring. When you can't combine your x or variable terms, you factor. So I factor out the common x, like so. Then I divide by that quantity to each side. Sometimes this will reduce. You should always explore that option. I'm going to say we're leaving it right like that, but we did meet our goal. X is now solved